Good morning, my dear students. So coming to the next experiment, that is what the next experiment is what balancing of rotating masses. Okay, so here I am going to explain you about the aim apparatus procedure and the calculation part and how to take the reading from the component. Okay, that is balancing of rotating masses component. Okay, so here there will be four masses will be there. So two is unknown and two are fixed known. Okay, so if you start initially the machine, the balancing rotating mass is going to vibrate. Okay, to reduce that vibration we are going to conduct this experiment. Okay, so here the aim of the experiment is what that to balance the rotating masses to reduce the vibration of the shaft. Okay, so if you look at the this experiment, the beginning there is a chance of producing a vibration. Okay, once if you according to the given calculation, those two masses you are going to fix there means you are going to reduce the vibration, okay, produced by the given shaft. Okay, and how we are going to calculate the two masses with the help of this force polygon and couple polygon. Okay, so aim is to balance the rotating masses to reduce the vibration of the shaft. Okay, so here already we know that what is static and dynamic. Okay, static means what here all the forces and effect on that particular component going to rest position, and whereas a dynamic means what all the forces and effect which are in motion condition. Okay, so here to reduce the vibration of the shaft we are going to conduct this experiment. Okay, so aim is what to balance the rotating masses to reduce the vibration of the shaft and also draw the force and couple polygon diagram. Okay, with the help of these two diagram you are going to calculate the unknown masses. Those unknown masses you are going to fix their particular shaft, you are going to reduce the vibration. Okay, so if you look at that in the video I am going to explain this in detail. Okay, what is the how the vibration going to take place and how it going to reduce the vibration. Okay, so what is the apparatus required is dynamic balancing machine required. Okay, and along with this a dimmer stator is required. Okay, so theory here I told you static and dynamic. Static means what it is a it is a one which deals with the force and their effect which are in machine components are in what in rest in position. Okay, whereas dynamic means what the forces and the effect on that particular machine component are which are in motion condition. Okay, that is the main difference between static and dynamic. Just to remember that static means rest position, dynamic means in motion. Okay, so how to conduct this experiment. Okay, so even if you look at the diagram, so according to that, okay, first you select the fixed arm of the reference arm. Okay, so select the fixed arm as a reference plane. Okay, there will be a four planes will be there. Okay, so first you are going to fix the what arm. Okay, that is a reference plane, you have to assume that. Okay, determine the distance between the arm with respect to the reference plane. Okay, once if you know the reference plane, so measure the distance between the what each masses. Okay, there will be four masses will be there, so you have to measure the length. Okay, and calculate the radius and the radius of the arm and the masses of the ball by using the force and couple polygon. Okay, there will be a two unknown mass will be there, with the help of force polygon and couple polygon you need to calculate this. Okay, so radius of the reference arm and the other fixed arm similarly. Okay, and determine. Okay, so here I will show you. Okay, so observation what here the mass of the A, okay, mass of the B they will give. Okay, so here I will show in the next PPT. Okay, diagram. Okay, look at here there will be, this is a balancing of rotating masses component, let us going to assume. So here the mass A, this is mass B and mass C and mass D. Okay, so here let us assume the mass A is what reference plane. Okay, let us assume this is a reference plane. From A to B you have to measure the length first. Okay, what is that you note down in the tabular column. Again from A to C, that is L2, that you note down in the calculation part, that is a tabular column, and L3 from A to D you note down this. Okay, okay, planes A can be assumed in horizontal plane and C can be assumed in the vertical plane. Okay, so these are the four masses will be there. Okay, so if you look at that the how I'm in the videos, so that you're going to understand better. Okay, first going to fix the reference plane. From reference plane you are going to assume what a length, and okay, from this plane to this is called as radius of rotation. Okay, that also you note down. Okay, so this is the tabular column. Okay, serial number you note down the plane 1 2 3 4. Okay, so how many planes are there? A B C D. So these are the A B C D. How many planes? Four planes will be there. Okay, so mass of A note down. Okay, so mass of A, mass of B, mass of C, mass of D, and radius of rotation. Okay, so they make you mass of this, and radius of rotation means what from this position to this position you note down here. Okay, distance from a reference plane B. Okay, so here you have to measure the length and note down there. Okay, from this to this initially 0. Okay, so from this point to this point, from this point to this point, from this point to this point to note down here. Okay, centrifugal force, with the help of centrifugal force what it is also called as what force polygon M into R. Okay, so this into this if you multiply means you are going to get this, and couple polygon nothing but M into R into L. So all you multiply you are going to get here. Okay, So finally you need to calculate the unknown masses B and D. Okay, so how much you are going to get these here in load, that masses you are going to fix in the balancing, then that whole vibration going to reduce. Okay, so here now coming to the calculation part. Okay, so mass of the ball A is equal to if you weight means you are going to get mass of the observation they given 0.186 kg. Okay, so mass of the ball C is equal to 0.187 kg. So you need to calculate B, A and D, you need to calculate here. Okay, so this is what the plane A, plane B, plane C, and this is a D. Okay, so let assume this is a B is a reference plane. Okay, from this to this measure what that is a I marked here round because here you have to assume that is a reference plane. Okay, so from reference plane to this consider positive values, from this to here you would consider as negative value. Okay, so and so here if you measurements you are going to get minus 0.032. So from this point to this point is 0.125, from this point to this point 0.157. Okay, from this to this is 0.192. Okay, so total is what 0.224. Okay, so this is called as reference plane. Okay, initially you can assume either A or B. Okay, if you are assuming A means consider from this point. Okay, from A point. If you consider B means you are going to consider from this point. Okay, now so mass of C is equal to mass of A is given, that is mass of A and C is given, that is 0.1867 and 0.187. Okay, substitute here mass of A is equal to 0.186 and 0.187. Okay, so mass of B and mass of D. Okay, you need to calculate with the help of force polygon and couple polygon. Okay, so if you want, if you these two are MB and MD are unknown, so if you calculate and substitute, you are going to fix here mass of C and D, then the whole balance is going to be takes place. That means what, reducing the vibration. Okay, so plane, how many planes are there? A, B, C, D are there. Okay, so radius of rotation is, if you measure from this point to this point, that is a radius of rotation. Okay, from shaft to the ball. Okay, you measure, you are going to get 0.095, 0.112, 0.095, 0.112. Okay, so centrifugal force, this into this, mass into radius. Okay, this and this if you multiply means you are going to get 0.01767. Okay, so and 0.112 into MB right here, 0.095 into this you are going to get 0.01776. Okay, 0.112 into MD is equal to, you are going to get this. Okay, this is called as a centrifugal force. Okay, and the distance from the reference plane B. Okay, so measure from the, you are going to consider this is as a reference plane, so B is equal to 0 instead. Okay, look at here, B is equal to mass of B is equal to 0. This is mass B is equal to 0. From this to this is equal to, take negative sign, from this to this minus 0.032. Okay, so again from here to here 0.125, so that is B to C is 0.125. Okay, B to C, again B to D is equal to what, so 0.192. Okay, like that you have to write here. Couple polygon means what, so I have to multiply here, formula I shown here, that is mass into radius into L. Okay, so this is mass, this is radius, this is length, you multiply all those three. Okay, you are going to get minus 5.65 into 10 to the power of minus 4. Okay, so second one is 0 is there, if you multiply anything means you are going to get 0 only. Okay, this into this into this, you are going to get 2.22 into 10 to the power of minus 3. Okay, so and this is unknown, MD is equal to 0.112 into this 0.192. Okay, you are going to get 0.021 into MD. So look at this, the last column here. So okay, so look at this last column. So here there are two unknown will be there, MB. Okay, so MB is unknown, that you need to calculate. Okay, MB. Okay, and here MD is also unknown, so you need to calculate with the help of centrifugal force. You need to calculate MB and MD. Okay, so how we are going to calculate, with the help of these values you construct the force polygon diagram. With the help of last column you are going to construct the couple polygon diagram. Okay, look at here, this is called as a force polygon diagram. Okay, so first you can draw any one couple polygon diagram also. Okay, so first force polygon diagram, how I am going to draw on this is, look at here, so force polygon, take these values. Okay, where is this force polygon? This is the force polygon. So first you draw the couple polygon diagram, because initially it is 0, so you have to start from this. Okay, couple polygon 0 to this A, so that is what, 0 to A is equal to minus 5.65 into 10 to the power of minus 4. That is you draw here. Okay, this 0 to A minus 2.829 minus 2.82 minus 2.8, where is that, minus 2.829. If you divide this, you are going to get what, this is what, couple polygon. Okay, so here you are going to assume some suitable scale, 0 to this side. Okay, negative is there, minus 2.829. Okay, so you are going to consider them some assume scale. Okay, that is 500. Okay, if you multiply into 5,000 means you are going to get this. Okay, minus 2.829. Again from this point to this point, again from this point to this point, what, so here look at this diagram. So this is the negative one direction is there, from this point to A to See, again you are using scale here. So if you use scale means you're going to get values what 11.11. You draw in vertical direction. Okay. So this from So from this to this is unknown is there. We don't have that you need to calculate. So join these two line. Okay. Unknown. Okay. So now the circle is now the closed one is over. Okay. The closed triangle is over. So now you calculate what this MD. Okay. So measure this with the help of scale, which is equal to what, this is equal to 0.0215 MD. So this one, okay, this one 0.025 MD. Okay, so this value into scale, so this is equal to the length of this. Okay, 11.4. if you measure from the scale means you are going to get 11.4 divided by scale. You are going to assume here scale is equal to 5000. Okay, so if you simplify this, you are going to get MD is equal to 0.1060 kg. Okay, this is what the MD. Okay, theta D you have to measure from this to this. This is 180 and this is 90. So you are going to get what, theta D is equal to 284.284 degree. This is rotated in anti-clockwise direction. So now what you calculate means at this theta, at this value, you are going to fix the mass of D in the balancing part. Okay, so MD is MD is equal to 0.1060. Okay, come to the one more is MD we need to calculate. MB is equal to, okay, how to calculate MB? Again same, with the help of these values. Again you have to assume scale here. Okay, so 0 to this one. Okay, 0.01767. so draw here here a negative direction, that is 0. How much this is 0? So here mass of B is equal to 0.112. okay, so this is a positive value is there. Okay, so this positive value is there into scale. So scale you are going to assume 500 into this 0.01767, you are going to get 8.8 something. Okay, draw that. Okay, so this is 0 to A. Again from this to this, what, from this point to this 0.017, that value into multiplication with a scale, you are going to get these values. Okay, so next one is what, this values. Okay, how to draw? Already we calculated MD, so that MD is substituted here. So again from this to this, whatever you are going to get value into scale, you are going to draw this. Okay, so this one. Okay, along this they given okay, so you need to draw that one. Okay, once if you drawn this, okay, so now last one we don't have that value, just to join. Okay, now it is a closed one. Okay, so now this is what, this is equal to what, 0.112 MB. Okay, so measures from the scale, you are going to get 10.2 divided by scale, so you are going to get MB is equal to 0.182. okay, kg. Okay, why you are going to draw here 90 degree? Because the masses are fixed in the 90 degree. Okay, because of that only we drawn here 90 degree. Okay, so this is this line we already calculated. Theta D is equal to 284. Measure and draw the angle. Okay, so here MB is equal to 0.182 kg. Okay, so if you simplify this, you are going to get mass of B is equal to 0.182 kg. Okay, and theta B, again theta B is equal to measure from this. Okay, this is the 180 degree plus this is equal to 45, so 195 you are going to get. This is the anti-clockwise direction. Okay, so now you calculated was mass of B and mass of D. Okay, these are the two unknown masses. Okay, you measure weight from this. Okay, from the weighing machine, 0.182 kg at an angle of 195 degree we are going to fix, and along with this mass of D at an angle, this mass you are going to fix at 284 degree. Then the whole balance, the machine component is going to be what, it will not be vibrate. Okay, that is this is what the calculation part. Okay, one this is a reverse of all the experiment. Okay, initially what you did, all the remaining experiment what you did means you have to first you are going to taking the values, then you are going to do calculation. But here first you do the calculation part and then measure and fix them these two unknown masses onto the balancing of rotating masses component. Then the whole machine component going to reduce. Okay, the vibration is reduced. Okay, so this is what, how we are going to draw the force polygon diagram and couple polygon diagram. Okay, this is about what, the balancing of rotating masses experiment. Okay, so here the main aim of this experiment is to reduce the vibration of the machine component. Okay, that is the main purpose. Okay, how you are going to reduce? Because there in the there will be a 4 plane will be there, 2 unknown, 2 known. Okay, so unknown mass you are going to calculate and fix at particular angle, then the whole balance is going to unbalance. Okay, that is balancing one. Okay, so I hope you understand this experiment, balancing of rotating masses. Okay, thank you. Okay, very good morning my dear students. Okay, coming to the next experiment. This experiment is called as balancing of rotating masses. Okay, so here the main purpose of doing this experiment is to control or to eliminate or to save the vibration in the machine component. Okay, that is the main aim to conduct this experiment. Okay, balancing, as you know, the balancing means we can both the sides should be same weight. Okay, so here so this is called as a balancing experiment. Okay, so these are called as planes. Okay, so this is plane A, this is plane B, this is plane C, and this is plane D. Okay, beginning we have to in the tabular column I explain about the tabular column. Okay, so that is what the plane radius distance. Okay, from this point to this point, exact middle, from this point to this point middle, you have to measure the length. Okay, from this point to this point to measure length, and this point to this point you are going to measure length. Okay, so now along with that you have to measure the radius. Okay, from shaft to this end. Okay, that is the radius of rotation. Okay, so while solving the problem we are going to understand this. Okay, that is calculation part. Okay, so here now so this is if you want to start that machine, the balancing setup going to vibrate. Okay, so the main aim of this experiment is the balancing of rotating masses. Okay, so if I start this machine, the whole body going to vibrate. Okay, so to eliminate, to control that vibration, we are going to measure some weight. Okay, with the help of this weight. Okay, with the help of calculation, what we did in the calculation part, according to that calculation part, what we find out the mass of A and mass of, that is mass of C and mass of B, that masses we are going to fix opposite direction, then the whole body is in what, stationary, that is we are going to control the vibration part. Okay, that is the main aim of this experiment. Okay, so I will repeat here okay, the main aim of this experiment is what, to control the vibration. Okay, so this is called the balancing setup. Okay, this is called the plane A, plane B, C, D. Okay, so now I will start how the vibration going to occur in this machine. Okay, so if you look at this, this is called as a dimmer starter. Okay, so it is also called as knob. Okay, once if you switch on that machine, so look at here how vibration going to take place now. Okay, just to give the just to give the speed here. Okay, okay, look at, just to increase the speed from the help of dimmer starter. Okay, just to observe the balancing of setup masses. Okay, so don't give suddenly the high speed, just to give the slow speed here. Okay, look at here, the whole component is going to vibrate. Okay, just to observe here, the experiment whole component going to vibrate. Okay, so to control this, we are going to find out what we calculated in the calculation part, that is mass of C and mass of B. That masses we are going to fix both the sides, then only we are going to control this vibration produced in the machine component. Okay, that is the balancing of rotating masses. Okay, so observe here, initially now it is vibrating. Okay, okay, now we have to eliminate this, we are going to calculate what, this weight. Okay, so this is about the vibration, what the vibration occurs in the balancing of rotating masses. Okay, now I will switch off the button. Okay, just close this. Okay, so in the second session what we are going to do is to control this vibration part, we are going to find what in the calculation part we already calculated mass of C and mass of B. That weight we are going to fix here. Okay, opposite, then we are going to start the machine, then it will control the vibration part. Okay, so in the first session, so how the vibration going to occur in the machine part we explained. Okay, I hope you understand this. Okay, thank you. Okay, now coming to second session. In first session what we studied, what complete this whole body is going to vibrate. Okay, so already in the first session we calculated. Okay, mass of C is equal to what, in calculation part I told you, in the mass of C is equal to what, 0.187 kg, and the mass of C is what, 0.186. okay, that you have to measure from the weighing machine. Okay, so these are the two components. Okay, so exact what you did, what you calculation, what you got the values from the calculation part, that is mass of C and mass of V, that you have to weight this. Okay, so these weighted are what, this is the plane C, and this is what you are going to fix. Okay, at point C, B and C. Okay, these are the weighted what you calculate. Okay, go and measure in the weighing machine exactly what you got in the calculation part. Okay, these weight you are going to fix here. Okay, so you are going to fix this is plane A. Okay, so this is called as a plane A. So this weight I am going to fix based on what you got in the calculation part. Okay, so that you are going to fix here. Okay, so here this is a one part. Okay, so second mass of C is got to 0.186. Okay, that also you going to fix, and here you are going to fix the opposite direction, not same direction. Okay, so you are going to fix here. Okay, these two masses what you got is you have to fix the opposite direction. Okay, so like this, if you fix this, now if you start that this balancing means it will complete unbalanced, that is what, complete balance one. Okay, so I will repeat, these two components, these two weight we are going to fix based on what you got in the calculation part. Okay, here, and while fixing you should show it should be in opposite direction. Okay, not in the same direction. Okay, so now, so based on according to the calculation we are going to fix the weight of, okay, in the balancing component. Okay, so now if you switch on this what, the balancing, so it should be complete balance one. Okay, so that is the main purpose of doing what, this experiment. Okay, so look at, just to slowly give the what, the speed. Okay, Okay, now look at here. So it will not balancing. Okay, so it will not vibrating. Okay, that is the main purpose of doing this balancing of rotating masses. Okay, so I hope you understand this. Okay, look at this. Both the masses in the beginning stage, in the first section video, the whole component is going to vibrate. But after fixing these two masses, it will not be vibrate. Okay, so this is the main purpose doing this experiment. Okay, what we conclude in this means we are going to control the vibration produced in the balancing of rotating masses. Okay, I hope you understand this. Okay. So like this you have to do this experiment, and this experiment is also there for the dynamics of machinery subject what you studied in the fifth semester. Okay, so I hope you understand this experiment. Okay, balancing of rotating masses. Okay, so thank you.